All good? Cool. Okay, hi everyone. As Madeline said, my name is Joel. I'm a PhD student in biomedical engineering, and I have worked with Python since I started my PhD about 4 years ago. And it's really changed the way I work with data. Before I used to use Excel a lot and do a lot of wet lab work or bench work. And since I started doing programming and using Python and a bit of R, when I came to Toronto, it's really opened my eyes to both how useful it is and how much fun it is. So I hope to be able to transmit some of that to you guys today, and get you excited about working with Python and get you to a point where you feel like you know the basics of doing data analysis in Python, and you feel comfortable in starting to look at things on your own and kind of keep developing after this workshop. Here's a little outline of what we'll do during this first morning session. I won't go through it in detail, but at the beginning I'll mostly talk, and then I'll put up some images and we'll do some live coding where you can code along and stuff like that. So since this is a beginner's workshop, I wanted to start with kind of an introduction to communicating with computer via text rather than graphical interfaces, where you point and click with your mouse as on your operating system, be it Windows, Mac OS, Linux, whatever you have. And before we get going, I just want to get an idea. How many of you have ever used a programming language before in some capacity? Yeah, there's quite a lot of you still. So maybe this will be familiar, but since not everyone has done this and it's a beginner workshop, we'll still go through it. So essentially, computing is about humans communicating with the computer in some way in order to modulate flows of current in the computer, so the computer can do what it's good at and carry out some kind of complicated computation that would be very difficult for us, or at least inefficient for us to do manually or mentally in our heads. So early examples of human-computer interfaces would be taking some kind of cable that goes into the computer in one spot, disconnecting it and connecting it somewhere else, modulating how the computer works, carrying out some kind of instruction in the computer. Luckily today, we don't have to do this anymore. You all have modern laptops, and it's very easy to kind of send your instructions to the computer, and the computer knows what you mean when you click these graphical elements, and it makes sense both to you and the computer itself. So you can think of these graphical interfaces as a shell around the internals of a computer, which kind of interprets information for the computer so it understands what you mean, and then the computer's information sent back to you so you'd understand what the computer has done. And one example of such a program that probably many of you are familiar with are spreadsheet programs, like Microsoft Excel, like LibreOffice Calc, or Google Sheets. And in these programs, usually all the functionality is accessible via hierarchical menus. So you have your menu bar, you go into File, Save, or Data, do some statistical analysis, etc. And the spreadsheet software definitely have its uses. For example, it's great for viewing and entering data, especially if these data sets are small. And you can create simple visualizations pretty quickly. However, it's tricky to design, to do more advanced things, like designing publication-ready figures, perform analysis that are easily repeatable and reproducible by other people. You can perform as advanced calculations, and it's also a bit difficult to reliably clean data sets. And that's part of the reasons why we will talk about how to do this in another way today using Python. Even if you are using a spreadsheet to kind of record your data, it's really powerful to couple this recording interface with a more robust analysis interface. So if you've never, now I know most of you already have done some type of programming, but if you've never done programming before, it might seem intimidating and a bit counterintuitive, maybe to type instructions to the computer. Why do we need to do this in 2018 when we have all these bells and whistles in our graphical interfaces? The way I like to think about it is kind of comparing it to learning a language. Like in the beginning, it does make sense to have something that you reference all the time. For the language, it would be a dictionary. Like I don't know the words to use in this different language. I need to go to the dictionary, look them up, kind of string them together one and one, and then I can communicate a complete message to whoever I'm communicating with. However, once I get more advanced, it will be much easier for me to speak this language directly or type it and say everything I want to say instead of having to go to that dictionary every time and look something up. And that would be the same thing. It's easier to type your instructions to the computer if you know what to say, rather than being limited by some kind of graphical menu where there is a delay where you have to go and find what you want to use. Text interfaces are also less resource intensive than graphical interfaces, and they're easier to develop programs for, since you don't have to kind of code this graphical component. And one of the most important things that's already touched upon, it's easy to automate analysis. Sure, you can do this to some extent in spreadsheet programs through macros, but if you like macros, you'll love programming anyways, because it's more flexible and more intuitive. So that's still a plus on the programming side. And this easy ability to automate analysis also facilitates reproducibility, not only between different labs, but also within the same lab, for example, and also between you and all your collaborators. And it's important to note here that your most common collaborator is yourself in the future. So you want to have done a really robust analysis where you know exactly what you did last year, because when you look at that data again, you might not remember exactly which order you clicked things in Excel, etc. If you instead have a nice recipe of typed up instructions in Python or R saying exactly what you did, it'll be much easier to just rerun that file than kind of remembering how you moved the mouse pointer last time. And as I mentioned, since text is the easiest way for people that develop programs to develop instead of coding graphical programs, a lot of the powerful programs that you might want to use are only accessible if you know how to use a text interface. And this goes for things like image analysis, machine learning, data spreadsheet kind of analysis, as we'll go through today. And just learning these skills in Python, as we do now, will also mean that you have an idea of how these things work, and you can transfer them to other languages like R, etc. Okay, cool. So let's get started with the basics. To communicate with the computer through Python, we need, as we mentioned before, we need something that interprets the language that we're going to type to computer code so the computer knows what to do. In this case, it's very intuitively called Python interpreter. Some people will call it command line, prompt, etc. But what we'll try now is to open that up and see if you can start Python. So if you're in Windows, you want to look for a program called the Anaconda prompt in your start menu. If you're on Mac OS X, it's your terminal, which is usually, if you go to Spotlight, type in terminal, you should find it. Just launch that and type in Python. If you're on Linux, whatever terminal you prefer. And okay, let me pull this up. So is this big enough for people in the back to, oh wait, we should do this. So your terminal should look something like this. Might not look exactly like this, might be white, might be black, might be green. You should have some kind of text interface where you can type in Python. Once you've done that, you should get a message like this. If you can get this message, please put up or keep your blue sticky up. If you're having an issue, please put up your yellow sticky, and we'll come around and help you.
Anaconda prompt?
Yes.
All number?
It should be 2 words.
2 words?
It should come up closely for discussion.
This is the window. You've got the windows in the front. Yes, you don't need
This is my first time. Yes.
I didn't just. Okay.
If we cannot, and I can give them space on this, this is a
That's
really
fine.
hard for me.
They want you to, it's not word like that. So they're using.
I mean, you could just answer.
I can make it bigger.
It's not sorry.
So you got that. Stop.
Yes.
And also, because, here.
If you can't find the icon from and only have the icon that navigator, you can launch the Qt console from within there, and it will be essentially the same thing. That might be a very recent update that you need. Yes, that's right.
Yeah.
So now you can.
But eventually, you're just gonna.
I think the jump to me.
Yeah. Okay. Yes, launch. Yeah. Yeah. There's a prompt that comes in Anaconda. Usually I don't know. Sorry, but this is the exact same thing. So that's all good. You see, I can receive message as I got there.
Yeah. So it's, so basic prompt. Unit before you open those.
Yeah.
So this is me. Wait. So that's okay. This is a text-based.
Okay.
That's what we're using. Resources, right?
Okay.
But that's just, you won't be using it. So it's just to check that you have it installed. You can see Python 3.16.
Okay.
So you're fine. This is just to check.
Okay.
From here, you can, computer, that's even, or from that one.
Okay, let's wait a little more so everyone can join.
Okay.
So you're fine.
Okay. Perfect. Thank you.
Okay, great. Let's move on. So what you have here, as I mentioned, is called a Python interpreter. So if you type something here, the computer will understand that's Python and it'll understand how to interpret those instructions. I might also refer to this as the prompt, and that's just because there should be a cursor here that's like blinking, prompting you to enter something. Some people call it the command line, might use those words interchangeably. I'm always referring to this. So while English and other spoken languages are referred to as natural languages, computer languages are said to be formal languages. You might think it's tricky to learn a formal language, but it's actually not at all. And sometimes I think it's easier than learning a natural language. And you already know one formal language, which is mathematics. And the good thing is that Python writes mathematics very much as how you would write it on your own. So if you want to, you can just type some mathematical expression in, hit enter, and you should get the result right back. So at its simplest, or I don't know about simplest, but like a bare bones way to use Python could be as a fancy calculator, if you so wish. And as you saw, it returned the result right under there, and it's kind of prompting us again to enter new instructions. So that's already happened, new line, what can we do next? This way of returning the result right away is another strength of Python in the context of doing data analysis. Some other languages, more traditional computer languages, need to kind of take this information, translate it into machine code or compile it into a separate file, and then we can run that file. In many cases, this is faster in terms of the execution speed of the file, but we have to do that extra step every time we want to try something new. Usually when we do data analysis, we do what's called exploratory data analysis. We're kind of digging into our data, we want to try something, and if that didn't give us the result we wanted, we want to try something else and kind of get the result right back again. So Python is really good for that. We can create a graph, get it right there. There's no intermediate steps. It's very interactive and a quick back and forth with the computer. And another advantage of formal languages is kind of the sparseness. So you can see the sparseness in this input is will be much quicker for you than typing something more natural like hello computer, can you add 4 and 5 for me and return the results. So it might feel like terse and succinct, but it'll save you time in the long run. Another big advantage of formal languages is that they avoid a lot of the ambiguity that might be present in English. Yes, I hear you. I'm an international student myself, and it's sometimes hard to know why something means 2 different things or doesn't mean that thing in that context, etc. And usually there's some kind of historical explanation that that's the way it is. Remember it. For computer languages, it's usually, that's the way it is, because here's a logical explanation to why that's happening. And that's much easier for me to understand personally, and I've learned to appreciate that a lot. Cool, so let's do so another thing that works kind of as how you would write math on a paper would be, say that I want to assign a value to a variable. I can type like, okay, my variable A that I'm creating now will be equal to 5. And then I press enter. You'll not get any output now because you haven't performed any calculation. You're just storing this value 5 in the variable A. And then I can perform a mathematical operation on A. So you can say A times 2. And then I get the output of that. So exactly like how you kind of intuitively would think it works. And that's really helpful. And yeah.
Are the spaces meaningful in Python?
White space in general in Python in terms of indentation will be meaningful, as we'll see later. These are not, but there is a kind of general style guide, and that's how it looks in that one. Yeah, and one last comment, I guess, is that just as when you're learning a natural language, I really find the best way to learn a programming language is to kind of keep trying it and keep getting direct feedback from the machine. It's like if you always have someone to speak with that knows that language perfectly, and they'll give you advice on what you did wrong and kind of not how to correct it maybe, but they'll know where to look, and then you can look it up yourself. So a lot of trial and error is really encouraged, and then when there's something you really can't figure out, go look it up. Cool. So although this Python interpreter on itself is very, very powerful, it's actually commonly bundled with a few other things when you use it for data exploration. So you get the more complete kind of data exploration interface. Sorry. One such interface is called the Jupyter Notebook, and that's what we'll be using today. And what we'll have you do is to start that up first, and then we'll kind of go through how it works. So if you want to exit your Python prompt, you can type exit. And if you had the Qt console up, it should close the entire window. If you launched it from a terminal, it should just give you your terminal prompt back. And oops. If you're in a terminal, you can just type Jupyter Lab and then press enter, which will launch it. If you were not able to find that terminal before, you can use that Anaconda navigator and just find Jupyter Lab in there, and you can click it, and that should launch in your web browser. So I will launch this. There will be a lot of text here. You don't have to worry about that. It should pop up a web browser window for you that looks something like this. If you can get here or to a similar web browser page, keep your blue sticky up. If you cannot get here, please put up your yellow sticky and we'll help you. So what you needed to type in, what's Jupyter Lab? We can do this. Or go to Anaconda Navigator and find that app and click launch. If you're not here yet, put up a yellow sticky and I'll wait for you. Otherwise, I'll move on. It might look similar to this, but not quite exactly like that. Yeah. Okay, so Jupyter originates from a project called IPython, which is actually what you launched if you launched that Qt IPython console, which was an effort to make Python development more interactive. And this is kind of taking it one step further beyond that. Since its inception, the scope of this project evolved, and it now involves many programming languages. So you can use R, Julia, Python, Bash, a lot of programming languages in this interface, and that's why it's called Jupyter. It's for Julia, Python, and R. I'll do some name explaining because I find it easy myself to know what a name means in terms of making me remember it. So this interface is not only great for you to kind of explore data, but also for you to share data and make sure that the data, the analysis you've done are reproducible and are easily distributable in a format that makes it easy for other people to run them as well. And we'll see that in a bit.
Sorry, Joel.
Yeah.
So that is for sharing our code?
So you'll see that you can do everything you can do in the Python interpreter here as well and more, but it also allows you to share your code easily,
Okay.
which we'll talk a little bit more about later. Yeah. Yeah. If you have any question, just interrupt me and ask.
So
Or
this
yeah.
will come with Python?
Yeah, so it's a good point. When you install the Anaconda distribution, as we asked you guys to do, it's essentially that Python interpreter you saw in the beginning. It's Jupyter Lab. It's some of the most common packages you use for data analysis. It kind of bundles some of these things together. So as long as you install that, it does come with the default installation. But technically, it's a separate app. So now click, so you can see here it says notebook. You can do some other things also. We'll get into that. Click the Python 3 notebook. And if you can't find that, you can also go to File, New, Notebook, and then you get to choose Python. I'm going to click there. And this thing we have here, which looks like that feed. I'm just going to do one thing. So you should be able to see a blinking cursor here. And if you type something in here, like 4 + 5, and then hit Shift-Enter, you should get the result back like before. The way this notebook is structured is you have these input cells where you can type text, and it's going to say in here on the left side. And then you have what's called output cells, which are just there to show the result of the computation that you did. This input cell is essentially the same thing we saw before in the Python interpreter. But it now comes with other things as well. But yeah, sorry. If Shift-Enter or press this play button, which says run the selected cell. So let's do exactly the same thing we did before. A = 5. And then now instead of executing this, we can actually, if you just press enter, you can write multi-line statements and execute it all at once. So here we'll do A × 2, and then we press Shift-Enter, and it executes both those statements and returns the result. You might have noticed that there's a little counter here to the left that says input 1, output 1, input 2, output 2. That's only to keep track on which order you've executed this, because I can go up again in the notebook and execute the first cell, and now this will be the third cell I executed. Although it comes before the cell, if you read top down, I actually executed them in the order 1, 2, 3. So that's just to kind of help you out. It exists there. These notebooks are saved automatically, but if you want to be safe, extra safe, it's always good to be extra safe. You can click this little save icon or Control-S. I tend to click Control-S all the time just because I like knowing that it's saved. There will be a small indication. You can see that there's a black dot there. It means that it's an unsaved notebook. If I press Control-S, it will change to an X, and that X is for closing, and that means that because there's no black dot there, I now save the notebook. If you want to rename your notebook, which we probably should do, you go to File, and you go to Rename Notebook. And we can call this Intro to Python. That file ending stands for the Interactive Python Notebook. You click Rename, and you'll see the name on the tab also changed. I have to remove it to get more real estate. Another thing that's great with this Jupyter interface is that you can type more than just code in it.
Yeah.
Oh, sorry. Yeah.
When you define variables, are they case sensitive?
Yeah. So if I say capital A is equal to 50, A × 2 would still be equal to 10. So now I create a new variable that's capital A. That's 50. Yeah, so if you want to create it, let's create a new cell under our current cell. You could either, if you press Shift Enter on the last cell, it will automatically create a new cell. If you just want to like insert a cell, it's this plus sign up here. And you'll get one there. And what I'll do now, that instead of writing code in this cell, sorry, I'm just going to do this so that it's higher up and you can see. Instead of writing code in this cell, maybe I want to take some notes about the code I just wrote. Maybe I want to create like this document that's a combination of my own notes to myself and the analysis I'm doing. What I can do then is I can go to code here, and instead of, or I go to the drop-down menu, instead of code, I select Markdown. Markdown is a text format. It essentially allows you to write comments and have some highlighting enabled. So for example, we can say that Kathy. So if I execute that cell, it will like that stay there as a note to myself or a note to my collaborator or my PI or whoever I'm working with. So I use this a lot to just describe what I'm doing, and also when I get results, I write some comment that like, okay, this regression made sense because X and Y, or it didn't make sense, and the reasons to why I was doing a particular analysis. So when I go back to this, I have like an entire document where I've written a lot of information that says what it's about, and I also have the code on how to do it. So it's really easy to reproduce. And it's also great for sharing, because one thing you can do with this entire format is that I can download it not only as a notebook, but also as a PDF, HTML page, or I think even Word document to send to others. To do that, you go to File, and then you go Export Notebook As, and then you get to select a few different formats. So if I do PDF, for example, I'll say, okay, open with, and I'll get a PDF file with all the code that we just ran. And it's kind of formatted in this nice PDF LaTeX-like format. You might have some issues if you try PDF now, because you will say, okay, you need to install this thing to be able to export the PDF. In the break or during lunch, go ahead and follow those instructions and see if it works for you. If it still doesn't work, we can help you kind of get that working. Because it's really powerful to be able to export these notebooks to PDF files and then send to people that don't have Python installed, and they can still take part of your analysis. But we'll try to do that later. So we'll close this. Go back to my notebook. I want to say a few more words about Markdown before we move on, just so you get an idea of what this syntax looks like. Okay, so let's go here again, code, change it to Markdown, and I'm just going to write some things in, and please code along, and you can keep this as a reference for later. So if you want to make a heading, you preface things with this pound sign. And that's, if you have one, it's the level 1 heading. If you make 2, it's a level 2 heading, so you can kind of nest your headings. Well, yes, let's do that. And then just do a few things. This is a bullet point. I'll leave that up there, just so everyone can type it in, and then we'll execute it, and we'll see how it's being formatted. And there will be some additional formatting tips in the lecture files, which you all have access to. Okay, here, less typing now. So if you execute that, you'll see that, okay, like it looks the way you would expect it to look. The headings are kind of nested. That's a bit bigger than that heading. And you can see that you can make this, use this asterisks or underscores, or you could also replace them with underscores to do emphasis and strong emphasis, or italics and bold. So this entire notebook is actually stored in a text format on your computer, which is called a JSON format. That's not super important for you right now, other than knowing that this is a format that if for some reason your Python like crashes and you can never open it again, that will not happen. If that would happen, you can still open this text format and you can read it. So it's not some obscure binary format that only the company who made this particular app can read. You can always read it in whatever text editor you use, like Notepad or text editor Mac. And before we get into the data analysis part, just mention a few more things about this interface. Make it a bit smaller so you can see. So you see that we have tabs here to the left. If you go to the Files tab, you'll see every single file that's in your current directory. And there's probably something there. So these are all my folders, and I launched it in my home directory. There's like a lot of files here. You'll have less files. If you go to running, you'll see all the notebooks that are currently running. We only have one. If you go to commands, if there's something you ever forget how to do, you can find it here either by searching for it or scrolling this list. And you can see also the shortcuts. For example, save notebook is Control-S. So this is really, really helpful to remember. Cell tools, don't worry about that. Tabs is just another way of having tabs on top. Don't worry about that. And one final thing I wanted to show you is that if I go to File, New, and say I want to launch where is it? A text file as well. I'll get two tabs like that. So this is just a normal text file called Untitled1 that's in the same folder as the notebook I created. So I can type things here, and I can also drag and drop these things so I can have them next to each other. So if you're, I don't know, writing some kind of summary in your text file while you're doing your analysis, like that's a good interface. And we'll see something else a little bit later that's really good to have like next to your notebook as you perform exploratory data analysis. For now, I'll close that and don't worry about saving it. Okay, so we're going to get into kind of an intro to the data analysis part. What I aim to convey with this part is just to make you kind of see how a data analysis workflow looks in Python, going from the beginning of reading in your data to producing some graph in the end, or some type of plot. And you feel free to code along. It's not essential that you understand every single detail that we're going to go through right now, because we're going to get into like more details about them throughout these 2 days. And this is more an overview, which you can refer back to, and also so you get an idea of what's going to come later, and that you have a conception of how it looks. Like maybe you know how to do data analysis in Excel, but how does it look when I do data analysis in Python? When you would do some operation in a spreadsheet program, you would go to the menu and click, say, File, Open, as we did before. The analogous thing to do in Python would be that there's no menu here, so instead we would type in our instructions. But the hierarchy of how they look can be very similar. So just as an example, you don't have to type this. Instead of going to the File menu, I would type something like File, Open. And then instead of getting this prompt where I can select my file name, I would type my file name in here. So this is not an actual command in Python. This is to understand how the syntax will look. And if you in the back cannot see, just let me know, and I can make it bigger. So since Python has many more functionalities than just doing data analysis, you can do like web scraping, machine learning, all kinds of things. Everything that you need to do data analysis is not there from the beginning. So you have to load some what's called packages, which you can think of, it's kind of like the App Store or Google Play. Your phone does not come with every single app installed. You have to download the apps you want. Since we downloaded an Anaconda distribution, we already have most of those apps installed, but we still kind of need to load them in our environment. And these packages, I should say that Python is an open source language, and although there is like an organization that kind of maintains it, anyone can make a Python package and distribute it. So you have access to all these cool packages made by great academics in different fields, and they're just there for free. And you're free to share your own packages as well to help other people. So to use a particular package that we already have on our computer, and now you can code along if you want, or you can just kind of like follow along with the flow. To use a package that I already have downloaded, I do the import statement, which means import this package into this current notebook. And then I say the name of the package, which in my case would be NumPy, which is the package used for, it stands for numerical Python. So a lot of numerical operations are done in NumPy. So if I execute that, let's say I've got a number, which means it has been executed. Nothing happened because I just imported a package into my current working space or namespace. And now I can use the functions that are in that package. So for example, there's no, in base Python, you can do some mathematical operations. But if you want to say, have a function that takes the mean of something or the median of something or the standard deviation of something, you need to import them from a package that has those functions. So now we can do something like numpy.mean, and then we can put in a list of numbers here. And again, the exact syntax is not important. It's a kind of general concept. So instead of opening my graphical interface, going to the NumPy menu and pressing mean and typing in my numbers, I type those three things after each other, separated by dot. So NumPy, this is my package. There's a function called mean in that package, which I happen to know. And then I open a round parenthesis, and in that we type a few numbers inside a square bracket. And we'll take the mean of those numbers, get more into details later. And the first thing I remember also when I started out is that, okay, how do I know the name of all these functions? Okay, mean, that makes sense. Maybe there's median, but what more is there? So a great thing is that it's very easy to get help. If you type NumPy, just a dot, and then you press tab on your computer, you'll get this menu, which actually lists every single function within NumPy. Yeah?
Can you zoom that? Because I think people are not seeing the square brackets.
Oh, sorry.
Yeah.
There's square brackets there in the mean. And we'll get into why you need square brackets, but not right now. Yeah, so let's go back to that. If you press tab, you get everything. If you just if you kind of know what you're looking for, you can start typing it. Say, okay, I know I want the mean or the median. I type ME. It kind of filters this menu automatically. First on the beginning, and then it does some fuzzy matching, finds things that has ME in general.
There's standard reference if I don't know what mesh grid is.
Yeah, so we'll get into how to find out what a function does in a little bit. Actually, maybe, yeah, we'll get into that right now. So very timely. Okay, I want the mean.
So sorry, how do I get?
Tab. So you press you do the dot, like NumPy or your package name, dot, you press tab, you get this list.
Really?
You don't get it?
No.
Yeah. Okay. So you'll get help. Okay. I want the mean, but maybe I don't know what it does, or maybe I don't know the exact syntax. Like, how did I know I want to have those square brackets when I enter it? A really great thing is that if you start the parenthesis and then you press Shift Tab, you'll get this little dialog that says exactly what the function does, and also kind of shows you how to use it. And we can scroll this, and okay, we can say, okay, it's numpy.mean. The first thing that we need to pass to it is this a argument. If I go down there, I can say, okay, a needs to be some kind of array of numbers, and that's what we passed it in those square brackets. And then you can also read general information. One really important thing that's recently added is this great help thing that's called inspector. So if you go to commands and you type in inspector, it'll tell you that you can open the inspector either by clicking there or pressing Control-I. I'll click here. I'll zoom out a bit just for you to see this. And apparently I have to reload every time I do that. So now you should have two tabs open. One's called inspector and one's your notebook. Drag this inspector tab to your right or left, whatever you prefer. Resize it a bit. And now if you do numpy.mean, all the information is going to show up there without you pressing anything. This is, honestly, this is one of my favorite things working in the notebook. So you open inspector, go to commands, open inspector, like drag that tab over there, and it will show you information, the help information about every function as soon as you type it in. I really like this. It's super handy to have it there. Use it. You don't have to use it. You can press Shift Tab after the parentheses or look things up online. I think that's a great thing to use. And if you want to know more in general, there's this help menu. So if you go to help, you have all these references for things to do. For example, what we're doing now is NumPy, so we can click the NumPy reference. It'll open a little page there. It'll have like a general, this is just a web page. You could open it online in your favorite browser as well. That's like a general introduction to what this library does and an overview of how the functions and what functionality is available. One common thing is in Python. Okay, so I will close the inspector because I need just more space up here. I recommend you keep it open.
Sorry, how do you open the inspector?
So you go to commands, type in inspector, and it's right there. You can also press Control I.
And how did you show the information through the recording itself?
Yeah, okay, let's open it. Next close. Yeah, so you see you have this tab up here. If you just left click and you drag it to the right, it should resize like this.
I meant beside the function itself. You press something to show like a small window.
Oh, okay, sorry. So that's if you press Shift Tab. So the inspector shows it just as you type it out. If you want to have this pop up, it's Shift Tab. Let's close that. Let's do this. Sorry? Yeah, yeah. Actually, yeah, okay. So another way of doing this is to do question mark in front, and you'll get the same information there. We'll show you that a little bit more later as well. But it's exactly the same information in different ways. I like the inspector. All these ways are great. Okay, so normally you don't have to use the full name of a package in Python. It's a little bit tedious to type NumPy every time you want to use something. So normally you import things with a nickname. So you say import NumPy as np, and then you can use np.mean. If you do this thing again, it's exactly the same thing. So we just gave it the nickname and we imported it to save some keystrokes as we type along, as we keep typing. Okay. Although NumPy stands for numerical Python, there's another package that's even better to use when you're working specifically with data that looks like spreadsheets. And it kind of is a layer on top of NumPy and has a lot of other things as well. This package is called pandas, just like the animals. It stands for panel data, which is an econometrics term that I'm not familiar with myself. So if you do import pandas as PD, I'll import the library. And now, if you want to, so I'm going to read a file from disk. Normally, you go to open file or kind of read file in a menu. What I do here is I do pd.read. And the file I want to read, it's a CSV text file. So it's read underline CSV. If you at some point don't remember this, remember if you click tab, it will be like, okay, these are the two options you have. Once you type read C, if you just type read, there are these options. Select CSV, keep moving. Okay, let's do some more of this. So now what I need to put there, it's either the file name where my file is located on my hard drive or somewhere online. So I can put in a URL, and that's what I will do now, just to make sure that people who want to follow along can follow along. That URL is in the pad. So if you scroll down here, it will say Iris dataset URL. So I'm just going to click it to show you how that looks. So it's just .csv means comma separated values, and that's exactly what these are. There's some kind of value, there's a comma, there's the next value, a comma, next value. So that's the next column. If you copy that, then go back to your notebook, and first you do a single quote, and then you paste that long line, and then do another single quote, and you close your parentheses. When you press Shift Enter, you should get an output something like this. Yeah.
Is there like a help menu or inspector for pandas? I don't see here when I click that, like.
Yeah, you should get it up the same way.
So that's okay. You get it. Right? So
Yeah. So if you don't,
When I first did it.
but sometimes maybe it's slow or something, but now it's like
you
really.
didn't run powers on here. Right? So it's already there. I mean, you can, but so you Oh,
Where can I get it? We should know this. I have enough.
So this is a web address I'm on board. Can you see it now?
No, it's been your own
Or do you have it?
Yeah, it wasn't this one. On the pad software,
It's not a software, it's just a web address.
the pad software.
Yeah, exactly. Yeah, so if you just type that in, you can find the URL.
You have to enter. No, here. Oh, okay. So it's done.
So it's fine.
This kind of this. So when you do something, there's no sort of done. Right, so you don't see anything. It's fine. Yeah, unless it's expected to be.
Yeah, but I don't have access. Yeah.
Yeah, so this is like the next one, right, which is I think that's yeah. So yeah, so it says to use the be in CSV and then it says here's the so that's the system.
So I want to show one thing. When you run a cell, you'll see that this number changes to an asterisk. You'll see that very quickly here. And then that means it's thinking. And when it's done, it goes back to a number. Sometimes maybe there's something on the internet or your computer is slower. You don't know why nothing is happening. Check if there's an asterisk here. It means the computer is still thinking, and just wait for it. If you, for some reason, need to restart your notebook, you press stop and then restart, which are these two up here. Stop and restart. And that will kind of like start over from the beginning, and then you can import the library again and run your functions again. So what happened when we read this CSV file? Is that pandas kind of took it and formatted it. I'll wait until they resolve this thing.
Wherever it is, but this is not a C drive, right?
I copied it.
Oh, all right, yeah, and to the
So it's right here.
Yeah. Yeah.
So what happens when you read in a file is that you get, instead of these commas, it reads it into what's called a data frame, and then it represents it like this. So this is kind of just formatting within the notebook that makes it look nice like this. And if you go over with your mouse, you can see it highlights the rows. So that's just a convenience you get from working in the notebook. However, what we want to do is we want to actually work with this data. We just don't want to display it. So we need to assign it to a variable first. So if you go to the beginning of your line and you type in like a variable name, I'll choose iris because this data set is about a few species of iris flowers and kind of properties of those flowers. So if I run this, it will now be assigned to the iris variable. And if I would type iris, like everything is there just as before. But since I have it in a variable, I can start doing computation on, perform different calculations with it. One good thing, instead of printing all of this, which is a lot, I'm going to do just iris.head, and just prints the first few rows. And we can do things like selecting a specific column. So you can see the column named here, and I can be like, okay, let's only take that one column of the petal length. spell it correctly. And I will do head again just to get only the first 5 rows so it doesn't go everywhere. Okay, you'll see that. Let's go up a little bit. You actually extracted those 5 values from that column. It's very easy to perform computations in the interface. If you want to get the mean from everything, every single column, you just type iris.mean. It gives you the mean value back for all those different columns. One thing that's something you commonly want to do when you're doing analysis is there is some variable that might explain variation in your data or explain why some values are different, and you want to maybe analyze your data in separate groups based on this variable. This is also quite intuitive. In pandas, you do iris, and then you say, okay, I want to group my data by something. In this case, you want to group it by the species, because different species have different properties on their flower parts. So you do, okay, group by species, and then you say, take the mean. And now you see that instead of the overall mean of all the values in that data frame, you get the means for every single species, for every single column. And again, don't worry if you don't get the exact details. We'll get into that. The general concept of how you use Python to do data analysis is what's important here. And so, okay, this is the syntax. We're going to see more later on how to do data wrangling or like crunching of numbers. If you want to visualize your data, we usually use an additional package that's called Seabourn or matplotlib. And you can kind of see the overall theme here. There are some special packages for different parts. And if we weave them all together, we get this very powerful environment where we can do almost anything, pretty much anything. So what I'll do now is I will import this package called Seabourn. SNS. That ran. One thing I have to do when I do visualizations, this might be a little bit different depending on which notebook version you're on, but I think everyone needs to do this. Is you run that line, which all this is saying is that, okay, instead of popping out in a new window, I want my visualizations to appear in line in this notebook. So just under the code cell, as when we're adding numbers together, for example. So say I want to count the number of species, the number of observations, the number of rows for each species. I could just do something like, okay, Seabourn SNS, let's do a count plot of the iris data frame. Sorry, excuse me, this x equals species, data equals iris. If you run that, you see you get the plot right here and under. All the observations had, all the species had 50 observations because this is kind of a toy data set, which is used to demonstrate different things. And you can see the species names down there. More useful might be if I want to compare one of the quantitative variables in the data set between the species. And for example, one thing I could do is what's called a swarm plot, which will make one, it's also called a dot plot because it makes one dot per observation. Exact same syntax, sns.swarm plot. X should be species again. And you say, okay, now I want my y value to be the sepal length. And my data is still iris. You run that. Sorry, sometimes my touchpad dies, but we'll work with it. So if you run this, you get that. So that's one line of code, and you get something like that. And you can kind of think yourself, if you would do that in a spreadsheet software, what would be involved in getting that, but probably a bit more than just typing this out.
Is it going back to the previous one?
Yes.
When we specify at the end of the argument data equal iris, what are we saying there?
So if we go back up, you can see that iris was the name I gave to this entire thing that I read.
Okay, so that's where we're specifying, you're plotting, this is the data from iris.
Yeah. I'll put that there so you can see that. Okay, cool. So we're kind of almost done with the first session. We'll have coffee very soon. Just a few more things that are interesting to see. So I guess first, yeah, well, that's evident. Yeah, let's do one last example to kind of get an idea of the power of doing analysis this way. So one common thing when I look at a data set, like let's take this up. This would be an unknown data set to me. Something I normally want to know right away is, okay, how do the relationships between these different variables or columns look? Do like sepal length correlate with the petal length, or more with the petal width, etc., etc., etc. One great way to explore this visually is to do what's called a pairwise scatter plot, which essentially makes one scatter plot for each pairwise relation, and then you can see if there appears to be a correlation. That's a great first step to look at. In Seabourn, this is super simple. You do SNS pair plot for pairwise relationships, and then all you need to say is that your data is iris data frame. It's thinking a bit because it's a big visualization. I'm going to zoom out a little bit so you can see both what I wrote and maybe also the plot. So it's pair plot, and then you say data equals iris, and you get this matrix of scatter plots with histograms on the diagonal. So those histograms are for each variable. So this is the histogram of the sepal length, and then of the sepal width, petal length, petal width. And then these scatter plots are the same. They're mirrored on both underneath and above the diagonal. And this would be the sepal width on the y-axis. And if you scroll down, you can see that on the x-axis is the sepal length. And you can already now kind of see that, okay, there definitely appears to be some groupings in this data. Like there's some values over here, then there's one over there. Okay, maybe there are two groups. Maybe here you could almost see three groups. Does anyone have an idea of why we have different groups in this data? Is there something in the data that could explain why the values cluster in groups? Three species, exactly. And something that would be really easy if we could just see the colors of the data points to represent the different species. And naturally, because it's an example we came up with, you can. So all you need to do is say that the hue of the points, the color hue of the points should be by species. And if you run that, you'll see that both the histograms and the scatter plots are now colored by their species. Yeah, and that was hue equals species. And if you go down, you'll see that these plots that we looked at before very nicely kind of colors as separate clusters based on the flower species they belong to, which does make a lot of sense.
Could you please scroll?
Yes, sorry. So the keyword to use was hue for color hue. This is the last visualization we'll do in the morning because I believe there's coffee, right? Yeah. And it's also very timely. So we'll take 20 minutes coffee. What do we do? 20 minutes coffee break? Yeah, let's take a 20 minutes break. You guys can go get coffee. And just to kind of recap, what we've done in the morning was kind of an introduction to both how to talk to computers, how to use Python, how to use this specific interface, the Jupyter Notebook, to do data analysis, because that's an environment we'll be in for the next 2 days. And then we went through an overview of how a data analysis workflow looks. We went from reading in our data, we did some calculations, and then we produced a visualization in that.
Sorry, I just have a question about the pair plot.
Yeah.
So there's one group for each column of our data.
Yeah.
But is it comparing it to all the others? I'm not sure what I'm looking at.
Yeah, so the easiest is to look at the lower diagonal. The scatter plots are mirrored below and above the diagonal. If you scroll down so that you see the x-axis, you'll see that the labels are here, so you know which different things are compared. So for this one that doesn't have labels, you would like go all the way out here, you see it's petal length on the y-axis, go all the way down, it's a sepal width on the x-axis. So if there are no questions, are there any questions? Yes, there are questions.
What's the matplotlib inline? Why
Yeah, sorry, that's a little bit obscure, and the only reason is that the default setting when you make plots is not to show them in the notebook. That might actually be the default setting on the version you downloaded. I'm not sure because I downloaded a while ago, but it tells, so it's explicitly saying that whenever I make a plot, show it in here. Otherwise, it might pop up as a new figure, depending on which version you have, your operating system, and something else that we're not have to get into. But it's just like a, what do you call it, housekeeping, a detail. Just, yeah.
One more, the Seabourn package is the one that's responsible for all of the visualization?
So Seabourn is a package that is great for statistical visualization. We'll talk about a package called matplotlib also, which is more imperative, which means that it's more like you're saying that, okay, I want to color these specific points blue, I want to color these specific points red. In Seabourn, you can see that all we said it was like, okay, just color the points based on their species. And then it takes care of some of these low-level things. So, but we'll use both this high-level Seabourn and the low-level matplotlib later. And if, as I said, if there are some details that are not clear, we will get into all of that starting after our coffee break, which will talk more about an introduction to Python in general, and also a bit about spreadsheets, when you can use them and how you should use them when you have to use them. Cool. So everyone, coffee break until 10:30. If you 10:35. So until 10:35. Just one thing, if you want to, we'll start in a few minutes, but if you want to follow along, I think we mentioned this before also, but just so that everyone knows, if you go to either the Etherpad or the Eventbrite page, there are links to the lecture notes where you can see everything I'm typing, like the finished notebook, and you can download that and save for later as well. So for example, on the Eventbrite page, if you go to morning part 1, that's what we just did. Morning part 2 will be what we're doing now. Morning part 2 is going to look like this. And then we're going to go through some of these lectures here. And then we're going to get back to some parts in this notebook, which was the other link I opened. So you might want to have those open if there's something. And also, of course, tell me if it's going too fast and I'll stop and you can read it. But this can be something that can help you as well. And here's everything that we just did. Scroll down, you'll see we have these plots and things like that. So that's available for you online. And that on the Eventbrite page and in the Etherpad, you have all the links here. Notes for session 1. And also up here. We'll start in a couple of minutes. I guess one note I want to make. Yes, we are running this notepad in a browser. That does not mean it's online. So even if you don't have an internet connection, for example, you can still use Jupyter. All a browser does is shows you a file in HTML or a few other formats. And it just so happens that most of the files you want to view are on someone else's computer, a server, somewhere else in the world. If you have one of these files locally on your computer, you can view that just as well as you view a normal web page. So the Jupyter files, they're stored in this text format on your computer, and your browser can view them no matter if you have an internet connection or not. Just a parenthesis if that was unclear. Or I didn't mention that, so now you know. Okay, so during the first 20-30 minutes, I'll talk a bit about spreadsheets and how to use them or what to use them for, where they are good and where they're not as good. And then we'll go back to use the notebook and we'll do more of a thorough introduction to Python in general, not only for data analysis. And after that, we'll have lunch. And after that, there will be kind of a deep dive into data analysis. You'll see more of mainly pandas today and different kind of data wrangling exercises. So spreadsheets. Spreadsheets are still good to use if you're entering data manually. You could use just text files for that, but there are some tools that we'll see where you can actually kind of validate your data as you're entering, make sure there are no mistakes, and automate some of those things. And those are good uses of spreadsheets. Some of the things where it can be difficult to use spreadsheets is that if you use spreadsheets for your raw data, but you store it in a way where you make, say, annotations that are human readable, like you highlight something, or you write a comment, like an actual Microsoft Word or Google Sheet comment. These things will not in anyhow show up if you read this data into a programming language and if you want to do your data analysis there. So will show how you can actually take notes in spreadsheets and what format you should have it in to make sure that if you use it for data entry, that data is still compatible with whatever analysis workflow you have. And there are a few images. You don't have to read what's on the screen. I'll throw up some bullet points, and I'll throw up some images, and I'll like highlight things that are important here. And the reason we are not teaching data analysis in spreadsheets, we're not going to do any statistics or anything, is a little bit what I already said, that it takes a lot of manual work, and it's easy to track. It's difficult to track what you've done. It's difficult to give to someone else, saying that this is how I got this. You click there, then you click there, then you click there. It's better to give them something that's like a few lines of codes, and then they just execute that. There's no room for like human error in misunderstanding them and what they did, or there's less room. There's always room for human error. So I guess I should just check. We asked before how many people use programming languages, how many people use spreadsheets in their research for anything. Most people also. That's good. We're teaching relevant things at least. So skip that. And you might also notice that if you want to use tables generate tables, or for example, figures for publication, it can often be quite tedious to do it. And it might be hard even to find like the specific statistical test you want to do or something like that. And because there's a lot of point and click, it's easy to do things like, say I apply one formula to a cell, and then to the adjacent cell, I by accident apply a different formula, and I don't see it because all I see is the result that formula generated. And like that's an example of an error that would be almost impossible to kind of spot unless you go through and click every single cell in your data and check what formula you use, or reapply the same formula, I guess. Yeah, let's get that. So one common mistake is a little bit, as I mentioned, that you treat a spreadsheet kind of as your personal lab notebook, and you make notes a little bit here and there, and you have multiple tabs, and you spread your data out, and it's very like it makes sense to you right there and right then, but it doesn't make sense to a computer, and we'll see an example of that soon. And we'll kind of emphasize the importance of setting up well-formatted tables that are easily computer readable. So one example of what you could do, we have an image here. So instead of say taking this, so this is a spreadsheet where I have different tabs. So I have my raw data in these two tabs, and I never touch that data. That's just my raw data, which I read in. I could also put them in different files, which might be even better. If I do any modification to this data, I should save them as either different tabs or different files. And if I want to take any notes about this data, I don't want to take notes in any of these four tabs. I want to have like a clear way of taking notes. A good way is to create a new tab just for notes. And here I can write like, okay, at a specific point in time, this is what I did. And you can describe what the spreadsheets are and whatever modifications you've done in that time. You could also do more advanced things like using version control systems like Git. This is not something that we're talking about in this workshop, so I'll not get more into that, but yes, mentioned, yeah?
Well, can you zoom it so that you can see the tabs?
Oh, yeah, sorry. Actually, apparently 300% is max zoom for Firefox. So I'll open something up in a bit where you can see more of that. So one of the most important things is this next part, which, oh no, it's huge. And it carries over to, this doesn't go only for spreadsheet, it carries over to whatever analysis you do. And before we read those things, I'm going to present you with a table. And in this table, there's something that's not ideal in terms of doing analysis on this data. And I wonder, we haven't covered this yet, but does anyone have an idea of what I could have done differently here to make it better? Yes?
Species and sex should probably be two separate ones.
Yes, exactly. Great point. Species and sex, having them in the same column makes things more complicated when I do my downstream analysis. So what I would want to do is I'm going to split them out into two different columns. And if we go back to these bullet points, we'll just talk about them one on one. So put all your variables in different columns, like weight, temperature, species, and sex. That should just be split up. They should not be combined together. Instead, each observation should be its own row. So there are cases where you want to present a summary table where this is not the case. This is about your raw data, how you should format it and present it. This is kind of the same as the first thing, no multiple information. Already mentioned that. Don't do things with your raw data. You're the only one who have a copy of that. You want to keep that copy intact. And you want to back it up a few times in a few different locations. And this last point we'll touch on more later. It's not a great idea to save your data in a format that's dependent on a vendor, a corporation, like could be Microsoft, Google, whatever. For example, many people have sometimes experienced problems using an old version of Microsoft Word or PowerPoint and then putting that file into a new version, or even worse, putting it on a Mac. Then you get into all kinds of problems. And you don't want like even if you know that all you do is here now and it might not change that much in 2-3 years, you might like be screwing over some later graduate student that comes in 10 years from now or 15 years from now and going to work with your data, and you use this specific format that's no longer supported or the company stopped making their software. You want to use a plain text-based format, such as the one we saw before, which can be read by any text editor, and it's not dependent on any specific organization or company. If when your data is formatted like this, we're going to refer to that as tidy data. And this will be more covered in the last lecture. But the general idea of tidy data is that every column, its own variable, one observation, and every row is one observation, and every column is one variable.
Would it not be better to do the dates, like the month, day, year separately?
Yeah, that's a good point. That's the other thing that's wrong with this. There are actually two things. And we'll get into that soon. Actually, is that the next thing? No, it's not the next thing. But yeah, so I have an example spreadsheet here. So I want to have one, before we get into more common mistakes, including how to format dates, I thought we could have a little bit of interactive session between you guys. So if you turn to your neighbor and do this 2 and 2 or 3 and 3, however you prefer, please discuss for 3-4 minutes things that are wrong with this way of recording data. And then we'll have a little bit of, like you can shout some things out and I'll talk more about them in depth and go through what you could do instead. So just turn to your neighbor and discuss how could you have done this in a better way in order to analyze this data robustly downstream from now. So 3 minutes, talk to your neighbor.
This one, I wouldn't have all the brands. Just make sure that the weight is all the same.
Oh, yeah. But yeah, that's just.
Yes, how is
Then I would have calibrated with uncalibrated.
Because just by adding. Yeah. Things without,
Yeah.
It might just be easier.
Because if we're here, then we'll do changes here.
Thanks so much.
Okay. Does any group want to start to give me some suggestions, or should I randomly pick?
So first off, you should probably just have a separate column for species instead of separate for each species.
Yeah, either have a separate column for each species, as you said, or if you, for some reason, absolutely want, no, that's the best thing, you could maybe have different tabs for them, but I agree that that would be the best solution. More things from another group?
Comparing across the three tables, the dates are in different formats. So the first two go day, month, year, and then the last one would go month, day, year.
Wait, this also goes month,
Month,
day,
month,
year.
day, year. And then the next one, sorry, goes,
month, day, year.
oh no, sorry, okay.
This is, although they are consistent, but it's not a good date format, which we'll get into soon. And one of the reasons is to get confused about kind of like what's what and how it looks. More things, yeah.
The way to change like the format to be like a number or a text. Like, some of them is like text, some of them is like number, integer.
Yeah,
Like,
because they added the unit here.
yeah.
So a better thing in that case would be to have a separate column that says what unit it is, or you could possibly indicate it in the column name.
Still the weight for the missing values, was it like not captured or is it 0? So
Yes, that's a very important point. How are we encoding zeros? In the case of weight, it will probably not be 0 gram, but in general, it's really important to have a consistent system where you say that my missing values are going to be blank, or they're going to be something else, but blank is usually the best option. And zeros are going to be encoded as zeros. I'm not going to treat zeros as blanks because they're not the same thing. A zero is something you measured. A blank is something you didn't measure because you're missing that data. Actually, let's show. Well, okay, let's get more things. Let's have one or two more things. I see a hand over there.
So the caption for the data collected was not necessarily recorded. The first caption is different.
This?
Is
Oh, sorry.
The caption date collected, the first.
Oh yeah, like the name of, yes, the column name?
Yeah.
Yes, that's a good point. These column names are not being consistent. Which of these column names do you think is better? Date underscore collected or date space collected?
Underscore.
Yes. Right. The reason is that some programs treat spaces as like a separation between arguments or something. I think it's two different things. But this is how we want to do it. One more thing. Yeah.
Should probably have your data starting call or in cell A1 as opposed to like a.
Yeah, that actually I don't know. Like, yes, that's a good point. I'm not sure if you would export this to CSV. If it would, yeah, I would probably treat it as just a missing field. So yeah, you should start at like the top thing. There shouldn't be a title here. That should be the name of your tab or your document. One other important thing we should get into soon. This, which ties into kind of what you said about the weights being different. Like, this doesn't mean anything to computer. You should have a new column here that says scale calibrated, yes or no. Okay, let's see if we missed anything. There's a thing here about all the common errors. So the first thing, which, as we said, we shouldn't have all these different things. Put the species, have like one tidy data. Not this makes sense to you, does not make sense to a computer. When you use multiple tabs, well, we cannot talk about it. We talked about this also. You need to fill in your zeros because they're not the same as missing or null values. And this, I wanted to show you this little table. Here's an example of what people can use for missing values. 0, not a great idea. You can read this on your own. You have the link to the lecture material. In general, the recommendation is to use blank. There are maybe some problems where you don't know if you're actually missing the measurement or if you did something wrong when you enter the value and it's just missing. but in general, it's the most compatible with different programming languages, and it makes sense that your missing values are blank. Other common things like NA, which is not available, or NAA, not a number, could be confused with abbreviations, for example, North America, etc. So that's the reason why that's not a great option. Yeah, so they didn't. So this is the thing we mentioned. Instead of doing something like this, highlighting or having that parenthesis we saw, you should have a separate column that says explicitly when you calibrated your device, and then you can use that column when you analyze your data. These are minor things that we mostly covered. This is what we said, every variable, its own column. And here's a good overview table of what's a good name, what's not that great name. And yeah, in general, use underscores, capitalization, doesn't matter that much. Having that said, I definitely prefer lowercase all the time, lowercase and underscores. But that's going to be a little bit different depending on the programming language and the common way of doing that in that community. And it might be different in your field, etc. But in general, avoid things that could be like mathematical operators or special characters and things like that. And yeah, metadata should be in its own. We kind of talked about it already. You don't make comments on the data, you put it in its separate thing. Cool. So let me just check. I think there's another example. Yeah, let's talk more about dates. So as we said, yeah, okay. Cool. So when you save dates, it might feel natural to type it in a way that you would type it in like your notebook or something. However, the problem with this is that when you use a spreadsheet program, it does some kind of internal representation of this date that might not be what you think. For example, in I think most versions of Microsoft Excel, you cannot type a date that's earlier, and you can try this now, that's earlier than 31st of December, 1899, I think, because internally it represents all dates as the number of days from that date, and they didn't have negative numbers. So it's not going to auto-format a date that's earlier than that date. And that could cause different problems. Another common thing is that if you have auto-formatting for dates enabled and you type in something that's not a date, it might be formatted as a date and therefore excluded. There are a couple of examples, at least, with gene names where people analyzed, I forgot which consortium it was, but there are gene names like for example, OCT4. Oh, I can just type this. There's a like the protein gene called that. Oh, there's a gene called these things. And if I would type this, now I actually have formatting turned off, but if I would type these things in, yeah, it might actually make it into date, and then when you export that date into a CSV file, it will convert that date into its internal number representation, and it'll be like a nonsense number in these fields. And you'll end up excluding those two genes from your downstream analysis, like unintentionally. So it's a great idea to turn off the date formatting and say that, okay, this is going to be text, this is going to be plain text. And it's usually if you have format and you can say like plain text or something like that. Or as was mentioned previously, instead of saying like a human readable date format, what you do is that you say that, okay, this is the year, this is the month, this is the day. And there are usually functions for this. I think even in Google Sheets, we can do like get the year from that date, and it will automatically transfer it. So if you have dates like this somewhere, sorry, first double check that they're correct, then put them in that more robust format. Could be a great idea. Save you some trouble later. Another way of representing dates that is a good idea is, sorry, I should have opened this tab before just to show you. So there's like a internationally recognized string representation, single line representation of dates, which looks something like the examples here. You just have to make sure that it's not automatically formatted, but if you make like a plain text representation and you have to have it in one string, you can't have 3 columns, you could use one of these, which is just a consecutive amount of characters with no white spaces. Just make sure it's not formatted as a date somehow by your spreadsheet program. That's it for dates. A couple more things, and then we're going to get back to coding. Fun part. So, okay, let's talk a little bit more about using spreadsheets for entry of data. So one good thing where spreadsheets are actually better than using like plain text is that you can validate that the data that's entered is what kind of data you expect in that column. So say this is the same as before, and this is a column for the weight in grams. I know for sure if anything is entered here, it should be a number. If it's anything else than a number, if there's something wrong in the data entry. If I'm entering like hundreds of these, maybe I make some mistake and I don't realize until later, it might or might not be easy to fix. Better is to make sure that that mistake never happens. So if in your spreadsheet program, it's similar in both Microsoft Office and LibreOffice. I'm going to use Google Sheets because that's what I have here. Sorry, if you go to data validation, there's going to be something that says, okay, I'm going to use it for this one cell that I highlighted. And I can set different criteria. So I can say that, okay, this has to be a number between 0 and 1,000. And if it's not a number, show me a warning. You can say save. And if I put in a number here, all good. If I put in something else, it'll be like a little red thing popping up. That's not that explicit. And if you click it, you'll see why it is invalid. I prefer to instead do data, go to data validation and say reject the input. And now, if you try to enter that again, it will be like, okay, that's an error. You can't enter like a character, letters as a weight, because we limited that options. And there are also things you can do here. For example, you know that, say this is the sex of the animal, you know it's going to be male or female. You can do data validation, and then you can say, you can input what values you can use, if I remember how to do this. And now you get like a little drop-down menu, and you see that there are only two things that you can actually choose from. And if you try to enter something else, you'll say that that's not something that goes into that column. So those are great if you are the one responsible for recording data, or if you have some kind of control of that process. You can recommend this. If you get data that's already recorded, it's a little bit harder. I mean, things you can do is, for example, sort data. Usually if you have some kind of weird values, they might show up at the top or the bottom, or you can do things like conditional formatting, where you highlight data that might be very much out of range that you think is a typo. But the best thing is to catch things when they happen. Kind of want to get back to the programming part. So this last part we already talked about. It's about exporting data. I can show you that. So we already mentioned these things. It's not a great idea to store data in a proprietary format like Excel for long-term storage. And that's, yeah, technology won't exist, as we mentioned, and won't open the same everywhere, even in the same software. And this is an important point I didn't touch upon yet, is that many consortium journals or grant agencies also require you to deposit your data in a format that is open and readable by anyone. So you can save yourself a lot of conversion process if you just do that from the beginning, and that's the way you work with data yourself. Okay. That's it, I think. Last caveat, if you're on Windows and you ever save something as a CSV file from Microsoft Office and it shows up and it looks like this on someone else's computer, it's because of the difference in how Windows and Unixes like Mac and Linux handles line endings, which is a bit obscure. All you need to know is that there is an option usually to not save only as a comma separated file, but to save as a, that will also change your line endings, but there's something called a Windows comma separated file, which you might want to use in Windows to ensure cross-platform compatibility. There was an image of that here somewhere, but it's just called Windows comma separated file. Yeah, here. So maybe you never have to worry about that. If you do, now you know it and you know where to look, and it's gonna take you less time to fix. Okay, cool. That's all we're gonna say about spreadsheets in this workshop. Good for data entry. Make sure to validate the data that is entered. Save you problems. Let's go back to our notebook, and let's do the second part of this session for about an hour, and then we'll have lunch. And as we said before, you can follow along. If you open it says morning part 1, but if you open that notebook again, it's going to be the second part of that, starting from Introduction to Programming in Python. I'm going to find my notebook somewhere. Okay, I'll make a completely new notebook. So you can either continue in the notebook you have, or you can go to New Notebook. I'll create a new one. I'll use Python 3. It's my only option. So as I mentioned before, this will be a little bit of repetition and like diving deeper into some of the parts and explaining exactly what's going on. So we'll start exactly what we did before. As you saw, oops, you can type in this cell. Remember, this is an input cell. Anything you type here, and once you press Shift-Enter or Control-Enter, both work, you get the output right under it. You can do any kind of mathematical operations. If you want to do things, there are some special syntaxes. For example, if you want to take to the power of, it would be like double asterisks. Well, that you don't know if that's. That would be as taking it to the power of. I'll do this so you can see. And one thing we didn't mention before, that this is not as important in the notebook because you have the ability to write text cells. But in general, if you have some like minor note that you want to include that you don't want Python to interpret, you can preface it with a pound sign, hashtag. And if you write something here, that will be like a comment to yourself and more like something like that. But as we said before, since we have this notebook interface, that it's not as crucial because you could go to, sorry, my touchpad idea. You could go to code, Markdown. You can be like, here you can actually write it instead and say that's, and you would have it like nicely formatted. Either way works. I usually use these things for like very minor thing, like, okay, remember what that function does, or there's a caveat here that you need to keep in mind when you're running the analysis. As we saw, we could assign things to values. We'll do this a lot, so I'll mention it again. If I do a equals 5 in that cell, in the next cell I do a plus 3. It'll remember the value of a, even if I do it in different cells. Doesn't all have to be in the same cell. This variable names can be anything. New variable equals 3, 2, and then you can say a plus new variable. And if you are lazy, like I am, or you want to avoid spelling mistakes, you just press tab. Once you started typing that, you get a little pop-up menu. You can select it, and then just execute it. Make sure everyone can see that. If this goes too fast, let me know. I'm going a little bit faster just because we talked about some of these things. Come on. One thing we didn't talk about is assigning, instead of values, assigning strings to variables. So I can have a string that's hello. And if I type the variable on its own, it's going to print out hello. So now I've stored not the value, it's a kind of value, but I haven't stored a numerical value in there. I've stored a text representation, which in Python is referred to as a string. And intuitively, you could actually add strings together. So if I have another string, which is called C, I call that string universe, execute that cell, get the number, you know you've executed it. Sorry, that's a bit far down. Do this to get more space. And then I say B plus C. What do you think will happen? Will it work? I see some nods. It will work. It will just concatenate those two strings. What I might want is a space in between. You can just add a space, say B plus space plus C. In general, get a feel for how Python works. what's going on. And as I mentioned, if I type just a value, it will remind me of what that value was. It will give it back out. If I want to type two values, like if I do A and then B on a new line, it will only give me the last value. So you won't print out 5 here, because by default, these cells only return the last value. If you want to see that value above as well, you'll have to add what's called a print, well, not statement. You will have to use the print function and says, okay, print this value. And now it's going to print first file and then give you back hello. And you can, of course, print this value as well. Formatting of things when you print them, it's slightly differently, and you don't get this out thing because it's actually not returned by the notebook. You're explicitly printing them. And you see that those quotation marks disappeared when you printed. It's just because printing does some formatting, like it will respect new lines, quotation marks, and things like that. Well, I don't know. Does that make sense to everyone? Any questions on that part? It's clear, cool. What's useful is that you can check what, and we'll do this more later, you can check what kind of types your variables are. So you can say, okay, I know A is 5, but what type of variable is that? And it's an integer, which means it's a whole number. And that's how it's represented internally in Python. It's good to be aware of these things when we store variables, because we want to make sure that we store them in a format that kind of is suitable for that variable type. Is it a categorical variable? Is it a quantitative variable, etc.? Things that we'll cover later. If I store a decimal number, the type of that is a float. If I want to check the type of the text I typed before, it's referred to as a string type. So this is a very useful function. We'll talk more about exactly what functions are later, but you saw them a bit already in the morning with like numpy mean, pandas read csv. This function tells you how Python represents this value internally, what type it is. A last type we'll do before we do a little challenge for you guys is that we'll talk about comparisons. So I can use standard comparison operators, greater than, equal than, equal to, greater than or equal to in Python. So if I ask is 3 bigger than 4, it'll say that no, it's not. This is false. This is a false statement. I can invert that by prefixing it with not. And just mentioning it because you'll see it commonly used. So if I execute this, I'm asked is 3, well, I'm asking not is 3 equals to 4. And that's the opposite of false, which is true. And this can get a bit convoluted, but that was false. Adding not inverts it, makes it true. You can also compare multiple things. So you can say, okay, is 3 greater than 4? And 5 greater than 1. This is false for the same reason as above, because although 5 is greater than 1, it's not true that 5 is greater than 1 and 3 is greater than 4. However, what is true is that instead of and, we say or, which asks if either of these statements are true. At least one of them is true. If either one of them or both of them is true, or will return true. While and requires both of them to be true. This will be useful later when we index data frames, because you usually do it depending on other values in the data frame and like cutoffs. And if you want to know what type of variable, what the type of these true falses are, they're called Boolean variables, which means that they are binary. They can only assume 2 values, which are true or false. And one last thing we'll do before the challenge is that sometimes, maybe not as much when you're working with data, but still sometimes you want to perform a certain type of operation if and only if one previous condition is true. So I can represent that in Python by saying, okay, if, I must check, what was A again? 5. So I can say if A equals to 5, print A is 5. since A was 5, it's printing A is 5. But if I reassign A now and say A equals to 4, nothing will happen. So this indented part, this is where white space becomes significant to your question earlier. If something is indented and it's following something above, either with a colon, usually with a colon, it means that this indented part belongs to that statement. So it will first check if A is equal to 5 and then determine whether or not it's going to continue executing the code or not. Can you see this in the back? It's good. Usually we want to do, as I said, maybe we want to do something else if A is not 5. And for that I can say else. So if A equals 5, do this, else print, and now just to simply say that A is not 5, because that's all we're checking. In this case, it does print 5 because A is 4. Changing it to 5, it prints A is 5 instead of A not being 5. Okay, we're going to have a mini challenge. So challenges are going to be ways of us kind of checking with you if these things make sense. You get like 5, 10 minutes, maybe 15 if it's a more involved challenge to work on something on your own, and then we'll check in with everyone and see if someone can either shout out or come up here and show what they programmed. So I'm just going to pull up that challenge from our online notebook, which I do have open somewhere. I'm going to give you 5 minutes to work on these 2 challenges. Can everyone see that? Can you see it better now? So yeah, 5 minutes, and then I'll check in that made sense, or talk about what didn't make sense, etc. Okay, so who can tell me what I should write to solve this first one? How do I assign A times 2 to the variable 2A? You can either, if you want to come up here and type it, you can type it, or you can tell me how to type it.
2_A equal A times 2.
Yes. Yes, now we can check. And then 2A equals 10. Second part of that question, what happens, so let's ask you, what happens when we change the value of A to 3? How does that affect the value 2A? It doesn't. Why doesn't it?
Because 2A was already assigned to 10.
Yeah, exactly. So if I hear...
The previous operation.
Yes. So if I hear in the next cell, exactly as was said, if I change the value of A to 3 here, A is indeed now 3, but I haven't changed 2A. It's confusing because it's called 2A and 2A is equals to A times 2, but it was assigned when A was still 5. So 2A is still, if I just do 2A here, it's still 10, because we executed 39, 40, 41 in that order. If I execute this again, 2A will change, because now I'm using the new value of A changed to A. Does that make sense? Any questions on this part? Cool, then we'll move on. Now we're going to get into more complex, but not super complex data types. So we talked about integers, floats, Boolean operating strings before. Now we'll talk about what happens if you want to have a lot of values together. You have to have some kind of array-like array-like type, and the first one we'll cover is a list. So, for example, I can make a list called planets, and I'll say this list will contain these 3 strings: Earth, Mars, and Venus. And then I just type out planets to see how it looks. You can say that, and we can also, just for clarity, say, okay, what's the type of planets? It's a list. These square brackets, when you use them in your assignment, that indicates that the returned object will consist of the values within the square brackets separated by comma. So this is a list of 3 items. And now we can access the items within this list using what's called Python indexing. And for example, if I do planets and I want the first item, the tricky thing here is it's not 1, it's 0. And that might or might not be tricky depending on how many computer languages you've used. Some computer languages start indexing on 1, some start on 0, with different advantages and disadvantages to those. In Python, it starts at 0. So if I want to get at the first element in this list, I say square bracket 0. If I say square bracket 1, the second one, square bracket 2, the third one, square bracket 3, there's no third one. There's no fourth one, so that it will give an error saying that you only have 3 elements, you're trying to get the fourth element, it doesn't exist. We can also index from the end of the list. So I'll just change this and say that I want the first element starting from the back. So that'll be -1, because you can't say -0. And we'll start getting the one at the back. So if I say -2, it'll be the one in the middle, and so on. If I make a new cell, so I can also get a subset of values, that it's not the entire list, but it's more than just one item.
So the negative number starting from right to
Yeah,
left?
yeah, exactly. That's, from the back or from right to left, exactly. I can get a range of values from the list, and this is called this is done by a syntax called slicing. So that's how they named it, saying you return a slice of the list. So here I'm saying, okay, from planets, I want to return everything inside this slice, 0 to 2. And if you remember, we said that Python starts at 0. So you might think that this should return 0, 1, and 2, but it only returns 2 items. This is because by default, slices in Python are inclusive of the first number, but they're exclusive of the second number. So it will be 0 and everything up until 2, but not 2. So 0 and 1. And we could see this by we could also do planets, and then we can say get Right. Oh wait, we can't do this. Skip that. One other thing we could do is, if you want to get everything from the beginning or from the end, we actually don't have to specify the 0 or the whatever the last number is of our list. You could just say that, okay, just get me everything up until that item. We'll see the syntax a lot when we use the data frames also, and how we kind of can get only certain rows or certain columns out of them. So it's good to remember the syntax already now. Similar to how we could add both numbers and strings together, we can also add lists together. So if I want to extend my planet lists, I can say planets should now be equal to planets. So everything from before plus this new list containing only one item. So I choose to be Neptune. Choose your favorite planet.
Excuse me.
Yeah.
So the number, is it including or excluding?
So the initial number here is included, and the second one is excluded. So everything up to the left of the comma is included, and to the right is excluded. And here we're just leaving out the 0, but there is an implicit 0 there, and then the first number, the second number is 2. So to add a list together, you would just use the addition operator, and so this, I should say that this part, we put it into brackets. We're essentially making a list here with only one item, Neptune, and then we're adding it to the planets list. Another commonly used programmatic logic control flow is loops, or for loops, as some people call them. We won't use this a lot in when you're doing our data analysis, but it's good to be aware of. And they kind of happen under the hood when we're going to use pandas and NumPy and Seabourn. But we don't have to bother with this syntax too much because there's already taken care of, and we can kind of express it a bit differently. But for reference, and still you'll probably use it sometimes, that's why we're covering it here. So I'm going to say for each planet in my list of planets, and planet here, it's a variable that I'm creating it right now. We didn't say what planet was before. We're going to say that go through this list of planets, and for every item in planets, it's going to be assigned to planet. And all we want to do is to print what planet is. And as you would expect, you do get all these 4 elements. They're just formatted a bit differently because instead of returning like one big list holding 4 elements, we're going through this list 1 item at a time, and every time we return only that 1 item. So this is that string, Earth, and remember when we did print, it took away those quotation marks, that's why they're not down there. And then it goes through, prints Earth, and it's like, okay, let's go up again. Now I assign planet to Mars. Okay, let's print Mars. Then go up again. Now I assign planet to Venus, and so on. So what you commonly want to do when you do for loop is just not printing something, but it might be perform some kind of operation and then return a result. So we'll just do something simple here. So you can copy this code. So just as normal, you would just highlight it. You can press Ctrl+C. You can go to the next cell and you can paste it. But instead of just printing planet, we'll print I live on, and then a space and quotation mark and say plus planet. So that's how the syntax would look if you're performing an operation and then returning something. And we could even do the exact same thing. I'll leave that up there. We say that I don't know, my string to print equals I live on planet, and then we can say print that's string. We'll do the exact same thing, just making it a bit clear that we're like assigning a variable, we're doing an operation, and then we're printing the result of that variable. One other type in Python that's very similar to a list, with the one difference that you can't change the item in it, which you can relist, is that actually, I should show you how to change an item in a list first. So if you remember how planets look, if I wanted to change one of these, I could say that, okay, planets at position 0, which is Earth. Let's instead make it, well, let's make it Mars also, because we're going to change it back. And now if I do planets, there are 2 Mars in the beginning. So this way of indexing can also be used to just assign something into that index position. But we'll change this back to Earth because, yeah, we might use it later. So let's change it back just so. So if you want to create an array of objects that you cannot change, which is useful for different purposes, we'll also dive into more later. You can use what's called a tuple instead of a list. And the difference here is that you use, you separate the values by commas only, and you don't have square brackets. Normally people have round brackets around them. You don't need to technically, but it's good because it kind of gives you a distinction of what it is. So we can make a tuple, and we'll do like, okay, that can be 1, 2, 3. And then if you print that, it'll return instead of square brackets, this round brackets around it. And just like with lists, you can do either value, numerical values or string values, or whatever you want.
So what exactly is a tuple?
Essentially, it's an immutable list, which means it's a list where you can't change the value within it.
Okay.
And we'll see this in this challenge, which I kind of gave away now, but that's fine. So let's go to the next challenge. I'll have it like that. Okay, so I'll give you, again, 3, 4, 5 minutes, whenever the blue stick is up, to try to solve this. And maybe take your blue stickers down for now, and when you're done, put the blue back up. If you need help, put the yellow up. Okay, so who can tell me the first question? What happens when I type a tuple? Yeah. So I've heard both. I sometimes say tuple, sometimes say tuple, I sometimes say tuple. Obviously, I'm not the authority you should listen to on this. But yes, you return a tuple, tuple, or tuple object. It's so that's the type of it, kind of as we said before. So okay, this second one is a bit slightly more complex. So maybe start with what happens when you type in planets 1 and assign it to 5. It modified the list and it became 5. What happens when you try doing this? You can try it.
Error.
Gave you an error. So if you say, and the error says that the tuple object doesn't do item assignments. An item refers to the items in the tuple or the items in the list. So that's why we said it's immutable. You can't change it. And we'll talk a little bit more about how to read these errors quite soon. So the next object we'll talk about is called a dictionary, or next data type, sorry. And lists are already, and tuples are very useful. Dictionaries are, I would say, even more useful. And they kind of think of them as containers that hold key value pairs. So something, and if you use that, you can index and get the other object. And we'll see how that looks now. So we'll make a dictionary, call it fruit colors, colors of fruit. And it will be equals to, so for dictionaries, so we know now for lists, it's the square bracket or just a bracket. For tuples, it's the parentheses, the round parentheses. For dictionaries, we're going to use the brace or the curly brace. And the syntax looks like this. Say banana, and then you do a colon, which means that banana is the key, and the value is yellow, and then comma. So the comma means that that's our first item, this entire thing. And now we're doing the second item, which also is a key and a value. And we're gonna do strawberry, and the color of that is mostly red. And then you end with that kind of closing curly brace. And as you can see in the notebook, when you're inside here, the braces are not highlighted, but when you kind of navigate to this brace, it will highlight the other one in green, so you can see which one are matching. And that's very helpful when you're looking for errors to see if you forgot to do the left one or the right one when you have multiples. So if we run this now, you'll see that it's exactly what we typed in. You have banana indexing to yellow, strawberry indexing to red. And now type fruit, press tab to get that entire thing pop up. And then we can say that, okay, what's the value that's associated with the key banana in this list? So I'm indexing, instead of with a number, I'm using these keys, which are in this case banana and strawberry. And we can also see that doing that, you'll say, okay, there are 2 dictionary keys, they're banana and strawberry. That last part you don't have to remember. You can also say, what are the values in this dictionary? So there are 2 keys, 2 values, and they are grouped in key value pairs. So to add an item to the dictionary, instead of just plussing it, which we could do, we could also simply say, okay, for fruit colors, I want to create a new fruit, which is apple, because that's a common one. And we'll say that apple is green. And if we now print all those, say that after we assign that position to green, it added the key value pair apple green. And this is very similar syntax to what we'll be using with data frames later to assign new columns. So now you're already seen it once. One important thing to know is that if I do a for loop for every fruit in fruit colors, by default, what this will do is, which we will see if I do print fruit, will print the keys. So a for loop in a dictionary goes through the keys only and not the values. When we're doing it with the lists, etc., there was only one thing, so there was no ambiguity there. Now, maybe you would think you will return both. It returns one of them. If you want to return the other one, you would simply use this key to index a dictionary. So say I want to return, so I would do fruit colors, and I would, index it. It should be a square bracket with fruit, and then it would return the colors instead. And I could also return both with a comma in the print statement. So first return the fruit, which is on these fruits, and then return the fruit color of that fruit. Let's make a quick note about error messages before we move on. So if I mistype something, if I use a key that doesn't exist, like say I spell banana like that, which is not unlikely that I would do, I would get an error message again. It's kind of, so let's compare that to the last error message. This one was a type error, which says this type tuple cannot do item assignment. Here is a key error saying that this key banana does not exist. And it's because I misspelled it. So already you get some help from what type of error it is, and you kind of get used to them over time. And of course, not everything will make sense the first time you see it, and that's fine. But worth noting here is that you have this error also. So if we would have a multiline statement, which we can just add some things just because, you'll see that it actually points to the specific line where there was a problem. So if you want to troubleshoot this, you know that this is where you should start. Okay, and those errors are commonly referred to as tracebacks or traceback errors. Let's do our last challenge, then talk a bit about functions, and then go for lunch. Yeah. So if we go to the next challenge. Sorry, it's a bit squished just because I want to have it big. So try to, 1, 2, 1. Try to solve those two. Put down your blue stickies now and put them back up again if you've solved it. Yellow up if you need help. About 5 minutes again. It's almost lunch and I see mostly blue stickies, so we'll go through this. Can someone tell me how to change apple to red? What should I type as soon as I get there? Hold on. How do I change the value of apple to red?
Fruit colors.
Fruit colors.
Square bracket and quote apple equal.
Let me check our fruit colors. We can even, let's just check them before to confirm that it was not red from the beginning. The apple is green there, and then we do this reassignment, and now we printed an apple is red. Great. What about that second part? How can we loop through fruit colors and print the key, the fruit, only if the value, the color, is red? Either tell me how to do it, or tell me how to do the first part, and we'll go line by line. Yeah.
Yes, there it is. So you need for some variable in fruit colors. You need a colon for the syntax.
Yeah.
And then you want indents, and then if fruit colors index some variable into double equals string that we want.
Yes, exactly. Great. So just to go through that again, we'll loop through the dictionary fruit colors, and this some variable is just a name that we make up for what we're going to call the items we loop through, so that we can reference them in here. So you could call it anything, some variable. It's a good name to show that it can be called anything. And then we make this conditional statement saying that only if fruit colors of some variable equals to red, then we want to print this variable. And just to make that clearer, you can see that in this last iteration of the loop, the variable we define will be whatever was last in the dictionary. So some variable right now is apple. So if we do fruit colors of some variable, you'll see that it is red. And it correctly printed apple as well. Any questions on that? Is that unclear for some reason? Otherwise, we'll talk about functions for 5 minutes, and then we'll have lunch. Everyone wants to get to lunch as quick as possible, which makes sense. So a function in Python is essentially these packages that we have used. They're like collections of functions that happen to be useful for a specific purpose, right? Like pandas for data analysis, NumPy for some numerical computing, Seabourn for plotting, etc. We can define our own functions as well, and we could even make them into packages later. It's not something we're covering here. But we'll cover the basic syntax of how to define a function. So a function is going to be a few lines of code, kind of describing an operation that we want to do with input, and then change it to some output. Similar to if you're like baking bread or something, and you have a list of ingredients, that's going to be our input, and then we have some kind of operations of what you add to what together, and then the output is going to be the final baked bread. So to define a function, the syntax starts with df to define, and we're just going to call this an add function. And what we're doing now is going to say it takes A and B, which means, okay, this function we're defining, you can give it two things. So we're going to be able to add maximum 2 elements, or we're only going to be able to add 2 variables together. And then we do a colon, and we get this indentation, which by now you kind of see that that's how we do when the indented code block is going to belong to this function. These are now the instructions that we write. So we're going to say that the result here is simply going to be A plus B, because this is an addition function. It's very redundant. We could just write that, but just to get the concept of how this works. And then here we're going to say, okay, what I want this function to return back to me. What is the like final product here? That is the result. If you run that, nothing happened, or it ran and it defined this function. I haven't executed this function, so I didn't get any output. It just said that, okay, now there is a new function that we can use that we'll define ourselves. So I can say, okay, let's use add function, and let's add like 4 plus 6. And you get the result panda. And we'll talk a bit more of details here. So what's happening here is that 4 is going to be A and 6 is going to be B, because that's just the order I put them in. And then I'm going to say that, okay, that's what's happening here is, okay, the result is going to be A plus B, which has to be 4 plus 6, then return 10, which is the result. That's how the syntax works. One thing that's important when you write functions that's very helpful is that if you give it a short description, just so that you remember what it does if it's more complex than this. And here we just say this, you do 3 double quotes. You don't have to do that, but that is the convention, so it's good to do that. This function adds 2 numbers. 3 double quotes. Nothing is going to change when I run this, because I'm just using the function. But if I want to get help about this function, if I do add function and then press Shift Tab, or if you have your object inspector open, this will come up automatically. You'll see the help message that we get. So docstring, which is this, actually was added to that part of the help section. So whenever you use another function like we did before, or whatever we use, like all these things that come up, that's someone who actually has typed it in like that originally. And we can see even more if we do if we do a single question mark, we see exactly the shift tab thing. If you do a double question mark, if you have something that you really want to know how it works, the internals of it, you actually can get the source code of that function. So we can do that on any other Python function, like the numpy mean stuff, the pandas read CSV. It might do some cryptic in some cases because it depends on that file and that file. But in general, you'll see exactly how something is defined by doing the double question mark, which is often super useful. And as I mentioned previously, much of the power from languages that are open source, such as Python and R, is the community around them. So there's lots of smart people, both in academics and outside of academia, that either do it for a living because they're for some reason paid for it, or just do it out of pure interest because they need it for their research. And they sit and they make these really complex functions that does, for example, some machine learning or some data frame operation that you really need. And then usually they release this as packages, which is what we've seen so far in pandas and numpy, which is a collection of functions like this that someone else has written and that you can use. We're going to cover packages much more in the next lecture, and we'll use them throughout. But this is kind of to get you an idea what is a package. It's not this magical thing. It's someone that has been writing functions like this, put them together, and usually not just one person, but many people. And then they're like, okay, we think Python needs like a data analysis library. And actually the story about Python didn't, I'm just going to give you this anecdote and then we will go for lunch. So Python didn't have a data analysis library for spreadsheet-like data, like R in terms of data frames. It's had like NumPy and similar things for a long time. But I think about 10, 15 years ago, there was basically one guy from the beginning who said that, okay, I think Python is so great in so many aspects, but we're lacking a good data analysis library. So he basically, I think he just graduated. He sat down for a couple of years and barely made ends meet and just coded away on this pandas library to make it as good as possible. And then by the end of it, people started discovering it and they're like, hey, this is really cool. And he had people starting to join him. And it's really that has now grown to being the most or the second most used package for data analysis across all programming languages. And it's because anyone can have an idea that I think this is missing. I'm going to try to make it as good as possible. And you either get some traction or you join another project or you merge your project with someone else and you can really work on that community feeling around something. And I guess that's also part of why we do workshops and our organization in general, that we also like this community around it, and we're trying to get more people involved and interested in these things. With that short anecdote, we will end the morning session. We'll go for lunch until, since I was a bit late, maybe come back 5 minutes after 1, that's fine. We don't have lunch. There's cold coffee, if anyone wants. There will be warm hot coffee during 1 hour after lunch. 1 hour after lunch, so you can get that here. I'll come at 1. Okay, cool. So that'll be here afterwards for you. Otherwise,
And one thing before you leave,
yes, sorry,
if you could write on your sticky notes, write something you liked on the blue one and something that you thought could be improved about the morning on the yellow one. This is very helpful for Joel and for us. Yeah.
I only read the blue ones. No, but seriously, it's super helpful for us, yeah. So we very much appreciate it. Yeah, and thanks, guys.